Hey guys, Mr. Hyatt here. In the last video, we left off talking about the trade-offs of recycling. Basically from there, how can we maximize the benefits and minimize the negatives? What hinders reducing recycling? Well, market prices often don't include harmful costs associated with products. One of the videos we watched recently talked about the fact that it costs more to have things fixed than it costs to buy a new product. I can remember at one point it was cheaper for me to buy a new printer with ink in it than it was for me to buy replacement ink. So that's not a good thing, because that means that the printer doesn't include the cost, the external cost. Often recycling industries get less favorable government treatment than large industries do. I don't have a lot of practicalities there. That comes from your book. And then the prices for recycled materials fluctuate. So it's hard to create a business when you don't know the costs of your materials, things along those lines. We can encourage reuse and recycling. We could include or increase subsidies and tax breaks for using recycled products. We could decrease subsidies and tax breaks on companies that make items from virgin resources, things that have never been used before, never been recycled, things like that. We can do enact new recycling laws, things like that. Citizen pressure, peer pressure is always a good thing. Fee per bag collection is a good thing. We've kind of talked through that. Excuse me, I skipped a slide. So basically we can recycle it, we can burn it, or we can bury it. So let's look at burning waste. I know that growing up my grandparents burned all their trash. Well, there are better ways to do that than just having a trash barrel that you light on fire. So there are 600 plants that turn waste into energy. So let's take a look at that. Here's kind of one picture. I think, oh, sorry, I thought that this had a bigger picture. But here's basically how it's going to work. The trash man is going to dump the waste into a big pit that a crane picks up. We dump the trash into a furnace. We burn the furnace. Oh, burning a furnace sounds like we're heating up water. Sounds like we can turn a turbine, which charges a generator, which makes electricity. And then, of course, we're going to have to cool it. We're going to have to scrub it. We're going to have dirty water that we're going to have to treat. We're going to have some ash that's going to come out. We're going to have a smokestack. So there's going to be some advantages. We're going to get rid of our trash. But there are going to be some disadvantages here and here. We got to treat the water. We got to get rid of the ash. We got to we'll still be contributing things to the atmosphere. So do we use scrubbers that are going to remove things? They're going to remove some things, not all things. So again, there are trade-offs. And here's some of our advantages and disadvantages for using waste to energy incineration plants. Burying solid waste also has advantages and disadvantages. Open dumps are big holes in the ground where we put a whole bunch of trash. Those are pretty rare around here because we use things called sanitary landfills. And here's a picture of that. Let me zoom in a bit. Okay, so when we have a sanitary landfill, we've got these leachate pipes. Leachate would be the liquids that are filtering down. So here's our waste that we've dumped in the ground and we've covered with dirt and typically some clay. We've got a leachate storage tank and a leachate treatment plant. Over here we've got basically stuff to capture methane, because this stuff is all going to ferment. It's going to release methane, and if we don't somehow collect the methane, it's going to be released into the atmosphere. Sometimes when you drive past landfills, you'll see pipes that have flames going at the top. And that's what's going on in that scenario. They're capturing and burning off the methane so that it doesn't get released into the atmosphere and deal with climate change and things along those lines. So that's kind of an example of a sanitary landfill. Again, we're going to have trade-offs there, so pause the video and read those if you need to. Next section is how should we deal with hazardous wastes. Hazardous wastes we're going to have to use integrated management for sure. Hazardous waste is a broad term. There are a lot of different types of hazardous waste. So we can either make less, we can convert it into less hazardous substances somehow, or we can store it in long-term storage. Here are some examples of that. Again, you can pause the video if you need a little bit more information there. We now revisit our e-waste study. 70% of that e-waste goes to China, and we've kind of talked through that at this point. If we recycle, we can reduce these toxic components. Oh, I'm sorry, we should reduce toxic components in our electronics. Let's find better ways to do this stuff. Let's find less toxic materials to make our cell phones work properly. Dell and HP recycle their products. You can send them back to the company, so there's a little bit of that cradle to grave. Apple does the same thing. Europe has these high-tech smelters that have really high standards, so we can do these things better. We just need to. One of the things on that last slide, or I'm sorry, 2 slides ago, talked about was detoxifying the hazardous waste. Let's make them less hazardous. Sometimes we can incinerate them using a plasma arc torch that's going to not quite vaporize them, but pretty close to vaporize them. But if it's a hazardous solid or it's a hazardous liquid, it's probably going to be a hazardous gas. So there are physical methods that we can break apart hazardous wastes and not make them so hazardous anymore. We can use chemicals or nanomagnets or some of these other processes. Let me zoom in again. Some other processes to make things less hazardous. Over here we see radioactive contaminants. So we use sunflowers to filter polluted water. We use rhizofiltrations, so again sunflowers, to filter out the radioactivity. It literally detoxifies the water. Over here we've got organic contaminants that things like willow trees and poplar trees can break down and absorb chemicals and can use them and then purify the soil and the water around them. Other other types of organisms can pull out other things like toxic metals, and lead and arsenic would fall under that. And again, can detoxify, can cleanse the soil. Here's the trade-offs of the plasma arc. You can kind of see that stuff. Again, basically, it almost vaporizes most things. Or we can store it. That's sort of what we do with our nuclear waste. We got to find a really deep hole that we can bury it in and not have to worry about it coming up through an earthquake or something like that. You see 64% of our hazardous liquid waste is just buried. Advantages and disadvantages there. Some hazardous waste we store in surface impoundments. We saw those with the mountaintop removal mines. We'll line ponds with rubbers or clays or things like that. They're impervious to water, and we just dump the waste in the pond and hope that it doesn't overflow and get into water supplies. So of course that's going to have advantages and disadvantages. Yeah, of course they can leak. They're holes in the ground. They can flood. There's kind of a hazardous waste landfill that would prevent some of those leaks. It's kind of a theoretical thing. Currently, we don't have a lot of those. Trying to skip forward to regulation here in the U.S. We always got to talk about the laws. 1976 Resource Conservation and Recovery Act basically sets standards for what you should do with hazardous waste. Cradle to grave responsibility. If you create it, you're responsible for storing it forever. But notice it only covers 5% of hazardous waste, so that's not making a significant dent. 1980, CERCLA, Comprehensive Environmental Compensation and Liability Act, set up the National Priority List. They're called Superfund sites. They're kind of the 1,300 worst sites on the planet that most need the attention. You can see 340 sites have been cleaned so far, but it's slowed down because the fund is broke. So there's no funding. So if there's no funding, you can't get anything done. So how do we transition? There are these grassroots organizations, not in my backyard, not in anyone's backyard. Basically, we have to hold ourselves and our organizations more accountable. I've talked a little bit about environmental justice, and this is a really good definition. Everyone is entitled to protection from environmental hazards. So, which communities in the U.S. have the largest share of hazardous waste dumps? Poor communities. Poor people are going to be stuck dealing with hazardous waste dumps because a dump is going to drive down the property value, and somebody that's wealthy is not going to buy that property. They're going to buy something that they can afford to live in healthily. So the only person that's going to buy land next to a dump is someone who can only afford to buy land next to a dump. And so that kind of falls under this environmental discrimination idea. Just because somebody can't afford to move away from it doesn't mean that I should be allowed to pollute their home. Excuse me. The Basel Convention, ratified by 195 countries, is the one we talked about, banning transfers of hazardous waste from industrialized countries to less developed countries. In 1995, that amendment took place. So that should be effective at this point, except we don't care about it. We're better than all these other industrialized countries. We can kill people in the third world if we so choose, because we're the U.S. We don't ratify those types of things. 2,000 delegates from 122 countries. We've already talked about this. The dirty dozen persistent organic pollutants. We've made some progress there. That's one that we chose to participate in. So we were able to help there. 2000, there was this law that was enacted in Sweden that by 2020 they want to ban all chemicals that are persistent and can accumulate in living tissue. So we've talked a lot about bioaccumulation and biomagnification. Those things are all addressed by this Swedish law. So the European Union is looking pretty heavily into that. There are societies that are ahead of us, and even pockets within the U.S. where we've made pretty meaningful gains. So we've got some examples of places that are having success. We just have to do it. Just have to do it. Last but not least, biomimicry is essentially using trying to mimic life. So we want to try to use natural principles to solve problems. So in nature, the wastes of one organism usually feed another. So can we do that in an industrial park? Can we make our trash, quote unquote, be fertilizer for something else? To do that, we have to understand how natural systems respond, and then we have to figure out how can we manipulate our industrial systems to fit biomimicry. How can we use life's processes in a responsible way to reduce our own waste?